So welcome to the laboratory. Today we are doing the Exploring Creation with General Science experiment 14.1, measuring your own cardiac cycle. The procedure for this experiment is published in J. Wile's Exploring Creation with General Science, second edition, published in 2008 by Apologia Educational Ministries. The purpose of this experiment is to determine your own cardiac cycle time under different conditions. And the only materials and equipment that you need for this experiment are a stopwatch or a watch with a second hand and a place where you can do jumping jacks. Now, before you actually complete the experiment, you should draw a table such as this in which you'll record the results of your experiment. So go ahead and hit the pause button and take some time to draw a table such as this if you've not already done so. So what we are going to be measuring is first of all, your pulse beats in 30 seconds. Okay, and so we're going to be putting that in this first column right here. And we are going to take that measurement 7 different times. We're going to start at rest before we exercise. Then we're going to do 1 minute of jumping jacks, and we're going to take that pulse beat in 30 seconds again right after that. Then a minute later, 2 minutes later, 3 minutes later, 4 minutes later, and 5 minutes later. Now, usually when we take a pulse, we're talking about beats per minute. But in this case, we're just doing it for 30 seconds because we're not really interested in the number of beats per minute. What we're trying to determine in this experiment is what's called the cardiac cycle. And the cardiac cycle is how long it takes the heart to beat one full time, one full cycle of the heart beating. That's the atria pumping and the ventricles pumping. Step 1 of the procedure tells us you have probably been sitting down quietly, or at least reasonably quietly, reading this incredibly interesting course. Although you have most likely been excited about all the wonderful things you've been learning, chances are good that you are close to your resting cardiac cycle. Thus, I want you to measure that now. To measure your cardiac cycle, place the index finger of your right hand at the inside of your left wrist on the thumb side. And you can see that here in the picture. Instead of just the index finger, I've used the middle finger as well next to it because I feel that it is easier to find the pulse that way. Lightly push around the area until you feel a consistent beat. That is your pulse. And then you're going to count the number of times your pulse beats in 30 seconds. And if you're having trouble finding your pulse there, you can feel for your pulse on the side of the neck as well, kind of underneath the corner of the jaw as it takes that angled turn by your earlobe, and you'll push in there until you can feel the pulsing. Now, it's important not to use your thumb to take your pulse because then you can actually be feeling the pulse in your thumb as well, and then that can interfere with your counts. Okay, so go ahead and find your pulse. If you're having trouble finding it, go ahead and pause the video. And if you have found it, we're going to go ahead and count for 30 seconds. And then we'll go ahead and record that in the table. So go ahead and pause the video here and count the number of pulse beats that you feel in that 30 seconds. Okay, so the number that I got was 38. So we're going to go ahead and put that in the chart here. Now remember, this is just for 38, is for 30 seconds. Now, if we were talking about my pulse or my heart rate, we would double that because obviously there's 60 seconds in a minute. And then that would be 76 beats per minute. But that's, again, not what we're interested in here. And it's step 2 of the procedure says, when your heart pumps blood into your aorta, the increased pressure in your arteries causes them to expand. that expansion travels through the arteries. And when you feel your pulse, you're touching an artery, and the beat that you feel is caused by the artery expanding and contracting in response to the heart pumping blood into the aorta. So in the end, each beat that you feel is corresponding to a heartbeat. And if you double the number of beats you felt in 30 seconds, like I said, you have the number of times your heart beats per minute. However, I want you to do something else. Divide 30 by the number of beats you counted. And this will give you your cardiac cycle, which essentially tells you how long your heart takes to make one beat. And then the average person your age has a cardiac cycle of about 0.75 seconds, which corresponds to 80 beats per minute. Okay, so I'm going to go ahead and do that calculation here. And the cardiac cycle, we're going to do 30 divided by 38. And I'll pull up my calculator here and do that math, and you should do the same where you are watching for your own. This is a great experiment that everybody can do, because it really doesn't require materials that most people don't have. And I'm going to round that to the hundredths place, and my cardiac cycle is 0.79. Okay, so what does that mean? That means that it takes 0.79 seconds for my heart to go through one complete cycle of beating. And there are actually 2 heart sounds that are produced for every pump of the heart, if you will. That is for every pulse beat that is felt. So again, we're counting our pulse beats, not actual heartbeats. But we're calculating is the cardiac cycle. So for me is 0.79 seconds. Okay, so before we go on, let's talk about our hypothesis. We're about to do a minute worth of jumping jacks of exercise. So what are we expecting? How are we, or are we expecting our pulse to change after that exercise? And so probably you have said yes, and the reason being is that when you exercise, your muscles are needing more oxygen to participate in that exercise, and therefore your heart needs to beat faster to be able to deliver more oxygen to your heart. So we should see that pulse go up. And when that pulse goes up, what do you think is going to happen to the cardiac cycle? Do you think it's going to take a longer amount of time for the heart to beat and then beat again, or is it going to take a shorter amount of time? And that's what we're about to find out. Okay, so after the exercise, counting the pulse for 30 seconds, I got 59. So obviously it was higher because my muscles were working harder. And we're going to go ahead and calculate the cardiac cycle there at that point. So again, we're going to do 30, but this time we're going to divide it by 59. And that, I'm going to pull up on the calculator, is 0.51 seconds. So the cardiac cycle has actually shortened because the heart is having to work harder. I should have put this in here. The heart is having to work harder and faster to get the blood where it needs to go to feed those muscles. So now you're going to go ahead and wait 1 more minute, and then you're going to go ahead and take your pulse again for 30 seconds. So go ahead and pause here, count a minute, and then take your pulse for 30 seconds. And then we'll record that in our chart. Okay, so 1 minute after exercise, my pulse had now come down to 40 beats for 30 seconds. So now we're going to do 30 divided by 40 to calculate the cardiac cycle. and I get 0.75. Okay, now go ahead and pause here, wait another minute, and then calculate your pulse again for 30 seconds. Okay, and here we are now 2 minutes after exercise, and I have gotten 38 pulse beats. Calculating that cardiac cycle. I'm just showing the calculations here. Okay, and go ahead and pause the video again. You're going to wait another minute and then take a 30-second pulse again. And again, I have gotten 38. And we've already calculated that at least a couple times before. Putting that in the chart here. After you calculate yours, go ahead and pause the video, wait another minute, and then recalculate your pulse for 30 seconds. And clearly my body has gotten back to rest here. And I'm seeing again 38 seconds. And therefore my cardiac cycle of 0.79 seconds. After you calculate yours, go ahead and pause the video, and we're going to wait one last minute and then redo your pulse one last time. And mine's 38 again. You might see some fluctuation, you know, if somebody walked into the room, or you just, you know, love science and you just can't, you know, stand it. Your pulse rate might go up because of that. There could be a number of reasons, or the caffeine that you drank earlier finally kicked in. You might see some fluctuations there with those last pulse rates, but they should be on the downward trend and getting back to your at rest before exercise. So notice what happened here. So started at 38. After exercise, it went really high, or higher anyway, and then it started going back down again, back down to that resting rate. Cardiac cycle, so it was at 0.79 seconds, but then right after our exercise, rather, it shortened to 0.51 seconds because the heart needed to get more oxygen to the working muscles. And then again, it hit a downward trend there. Thank you so much for joining me in the lab today. That's it for now. See you next time.